All right, let's see here. This is Algebra 2, Lecture 9, 16, and 17, OS A2, N11, and A2, N12. The student will add, subtract, and multiply imaginary and complex numbers, which I will define for you, imaginary numbers and complex numbers. And I'll show you how to add, subtract, and multiply them today, and then we'll get into dividing them later. Okay. So first thing I want to introduce is the idea of the imaginary unit. If we ask ourselves, what is the square root of 25? We would say, well, the square root of 25 is 5, because 5 times 5 is 25. If we ask ourselves, what's the square root of negative 25? We stop and think, and we don't have to analyze it very much before we realize that there's no real number that I can multiply by itself that will give me negative 25. Negative 5 times negative 5, multiplying the number by itself, that gives me positive 25. And 5 times 5, of course, is positive 25. I've had some kids say, well, what about 5 and negative 5? We can multiply those together and get negative 25, but the square root of a negative 25 is the number that I can multiply by itself. Okay? And if you're multiplying 5 times negative 5, you're not multiplying a number by itself. So what we're going to do is come up with the mathematicians to solve some problems in physics. We needed to know how to take the square root of a negative, and so we came up with a method. We invented another number, so to speak, and we call that number I. It looks like a variable, but it's not. It's an actual number. I is defined as the square root of negative 1. It's called the imaginary unit. I is the square root of negative 1. That means if you multiply I by itself, you get negative 1. I is the only number that you can multiply by itself that will yield a negative. For instance, negative 9 times negative 9 is positive 81. Any real number, if you multiply it by itself, you're always going to get a positive value. I, the imaginary unit, is the only number you can multiply by itself that will give you a negative value. And in this case, it would be negative 1. I squared, I times I, is negative 1. The definition, I is the square root of negative 1, tells me that if I multiply I by itself, I squared, I get negative 1. And now we can take the square root of negative numbers, and I'll show you how, hopefully. At some point, though, we're going to, in today's lecture, all we're going to do is add, subtract, and multiply imaginary and complex numbers. These are imaginary numbers. A complex number is what you get if you have this form, and A and B are some numbers. And if I had something like 3 plus 2i, this would be the real part of the complex number, or real number plus, and this would be the imaginary part. So real plus imaginary is just what we call a complex number. It's just a definition. You'll hear me say complex numbers, and all that means is I'm taking a real number and I'm adding an imaginary number to it. Here are some examples. 3 plus 2i, a plus bi. A is 3, b is 2. Here's another example. 4 minus 5i. A is 4, B is negative 5. Okay, so here's my real part, here's my imaginary part. If you have a real a complex number that you can't see the real number part of it, we say it's a pure imaginary number, and that the complex, or the real part, is a 0. A plus 2i. 0 plus 2i, rather. And we usually don't show that. We call that pure imaginary. Complex. I mean, the word complex makes it sound like it's really hard, but it's a label that they slap on it. It doesn't mean it's complex. It's just real plus imaginary. So here we go. Let's take a look at adding and subtracting complex and pure imaginary numbers by combining like terms. And that's how we add them and subtract them. We can treat them very much like variables. I's, we can treat them like variables as long as we're adding and subtracting. They're not variables. I is the square root of negative 1. It's a number. But when we go to combine them using addition and subtraction, we can treat them like variables, which is to say we can combine like terms. And that's what this is. We add and subtract complex and pure imaginary numbers by combining like terms. It's pretty simple if you look at it like this. Here's a complex number. I'm going to simplify it. I'm going to add the real parts to the real parts. I'm going to combine like terms. These are different signs, so I'm going to subtract and keep the sign, the one with the greater absolute value. And I'm going to add these parts right here, the imaginary parts. And that will give me 5i minus 2i. That will give me positive 3i. And I'm done. I took this complex number, real numbers added to imaginary numbers, and I simplified it into this complex number. A plus bi is the form that it's in. A is 1 in this case, and b is 3. Okay. Here we've got one that I want to simplify. Again, all I'm doing is adding and subtracting. And when we add and subtract complex and pure imaginary numbers, we just combine like terms, just like it was an algebra 1 or a pre-algebra problem. If I were going to combine these like terms, the first thing I would want to recognize is that this minus sign outside this set of parentheses, there's an implied negative 1 right here that I'm going to distribute. I'm going to take this negative 1 and distribute it throughout that quantity. In other words, it's going to change the sign of both of those terms. So I'm going to wind up with 8 plus I minus 3, negative 1 times 3 is negative 3, minus 5i. And now I combine like terms just like these were variables. They're not variables, but I can treat them like variables as long as all I'm doing is adding and subtracting terms. So I'm going to add my constants together first. 8 minus 3 is 5. And I'll add my imaginary parts now. And I have negative 5i plus 1i. Well, they're different signs, so I'm going to subtract. That'll give me 4i. And I'll keep the sign of the one with the greater absolute value. And there's my complex number. That's a simplification of this mess right there. Okay? So we just simplified by combining like terms if all we're doing is adding and subtracting. We treat them just like variables, even though they're not. This is real plus an imaginary number. This is real plus or minus, in this case, an imaginary number. They're complex numbers. Let's take a look at multiplying. It says we multiply complex and imaginary numbers as if they're variable expressions. So we treat them just like they're variables again, but we must remember that I squared is negative 1. The definition of the imaginary unit I is I equals the square root of negative 1. That means that if I multiply I by itself, I get negative 1. Just like if 5 equals the square root of 25, that means that 5 times 5 is 25. I equals the square root of negative 1 means that I times itself is negative 1. So when I'm multiplying imaginary numbers, anytime I multiply I times I, it's going to turn into negative 1 because it equals negative 1. I just got to keep that in mind. Otherwise, I treat it just like a variable unless I multiply it by itself, at which point it becomes negative 1. So we multiply complex and imaginary numbers as if they are variable expressions, but we must remember that I squared is negative 1. So here we go. Let's see what we got here. I got negative I squared. Well, that's negative times negative is positive. So I have, let's look at it this way. Negative I times negative I. Whoops. Doesn't negative I. Better yet, I'll look at it this way. Negative I squared is negative I times negative I, and that would be, I'll go ahead and do what I was doing before. Negative I times negative I. This will give me the I squared, and negative times negative is positive. Whenever I square this negative in here, negative times negative is positive, this is going to give me positive I squared. And I squared, by definition, is negative 1. I squared is negative 1. I hope that made sense. This is just negative I times negative I. Negative times negative is positive. Positive I times I is I squared. Positive I squared is negative 1. Kind of stumbled through that, but hopefully that made sense. Negative times negative is still positive, but I times I, by definition, I squared is negative 1. So it's a little tricky there, but not too bad. Here I've got, let's take a look at this one. This will make it a little clearer, I hope. This is 7i times 7i. You can think of it like this, 7i times 7i. You don't have to think of it this way. But 7 times 7 is 49. I times I is I squared. You could use that, the property of exponents, that if you have the property of the power that's over a product, each term of that product is raised to that power, as long as this is a product. So you got 49 plus times I squared. And this is 49 times negative 1. I squared is negative 1. 49 times negative 1 is negative 49. So 7i times 7i is 49i squared. 49 times negative 1 is negative 49. Hopefully that's sort of making sense. Let's take a look at this one. I want to distribute this. Let me get rid of this right here. I want to distribute this, and then all I have to do is remember, if I multiply I by itself, I squared, it turns into negative 1. And then I just simplify like normal. So I'm going to go 4i times negative 4 is negative 16i, just like it was a variable. 4i times negative I is negative 4i squared. Now I can't simplify this any further because that's not I squared, but I can simplify this one. I squared is negative 1. So this is negative 16i minus 4 times negative 1. I squared is negative 1. Negative 4 times negative 1 is positive 4. And then to put it in standard complex form, you put the real part first. That's this up here, the standard complex form. Real plus imaginary. So I've got down here, I have a real number plus an imaginary number. I'm just going to put the real number first. 4. And in this case, since this is minus 16i, I'm just going to say instead of plus negative 16i, I'll just say minus 16i. Okay? So I multiplied by using the distributive property. That gave me negative 16i minus 4i squared, I times I. I squared is negative 1 by definition. And then I said, well, negative 4 times negative 1 is positive 4. And then I just switched them to put it in standard complex form, a plus bi. In this case, b is a negative 16. Okay, let's take a look at this one here. I've got a complex number, negative 3 plus 8i, times another complex number. We're just going to FOIL it, combine like terms like we did in Algebra 1, and remember, if we run into I times I squared, it turns into a negative 1. So here we go. I'm going to take this and multiply it by both of these. I'm foiling. You can think of it as using the distributive property twice. I'm going to distribute this one, and then when I get done, I'm going to distribute this one. F-O-I-L. First, outside, inside, last. You may remember that from pre-algebra in Algebra 1. Here we go. Negative 3 times 5 is negative 15. Negative 3 times 5i is negative 15i. Now I'm going to take my 8, positive 8i, and distribute it. 8i times 5 is positive 40i. And 8i times 5i is positive 40i squared. And I'm going to draw a little firework thing here. Whenever I see I squared, I have to remember that I squared is negative 1. So when I rewrite this, I'm going to call that 40 times negative 1. I'm going to rewrite it calling it negative 40. That's 40 times negative 1. Because the definition tells us that I is the square root of negative 1. Therefore, I squared is negative 1. Now I'm just going to combine like terms and remember to call this negative 1. So these two terms right here, these two middle terms will combine. They're both I terms. And we add or subtract imaginary numbers just like they were variables, just like we did up above. So I'm going to wind up with negative 15. 40 minus 15 is 25. It'll be positive 25i. And then plus 40 times I squared. Well, that's 40 I'm thinking this is 40 times negative 1. So there's my negative 1 right there. That's negative 40. So I'm going to say minus 40. And now I've got these like terms I can combine. I've got negative 15 minus 40. They're the same sign, so I'm going to add them together and get negative 55 plus 25i. Okay. And we're in standard complex form, a real number plus an imaginary number. Negative 55 plus 25i. See, when we're multiplying, we treat them just like they're variables, just like it was an x or a y, except when we see I squared, it turns into negative 1. We have to remember that. Okay. And here's one more example of the type of problem you might see. If you have the quantity 5 minus I quantity squared, just remember that that means 5 minus I times itself. That's what a quantity squared means. 5 minus I quantity squared is 5 minus I times 5 minus I. So I'm going to FOIL this just like I did above. Combine like terms and remember that if I have I squared, I'm going to get negative 1. Here I go. I'll try not to mess it up. 5 times 5 is 25. 5 times negative I is negative 5i, just like it's a variable. The only time we don't treat it like it's a variable is if we multiply I by itself. I'm done distributing this term. Now I'm going to distribute the second term. Distributing the negative I. Remember that the negative travels with it when you distribute it. So negative I times 5 is another negative 5i. And negative I times negative I is positive. Negative times negative is positive. I squared. I times I is I squared. And here, my little firework shoots off again. Whenever I have I squared, that turns into a negative 1 by definition, because I squared is negative 1. That's the definition of the imaginary unit. Okay. So now I just combine like terms and remember this is negative 1. So I got 25. These will combine to negative 10i. We just add them and subtract them like they were regular variables, even though they're not. That's the square root of negative 1, and so is that. But since I'm adding them, they're not going to turn into negative 1. Negative 5i minus 5i, they're the same sign, so I add them together, 10i, and I keep the sign. And now I have this I squared here. That's actually I times I. I squared is negative 1, so that's a negative 1 right there. And now I can combine these like terms right there and there. 25 minus 1 is 24, minus 10i, and I'm in complex form, a plus or minus, bi. Here a is, I'm in this form, a plus bi, that's complex form. The real part is 24, b, the coefficient of the imaginary number is negative 10, a plus bi. You don't have to show this, that's just the form I put it in and then I stopped. And if I were looking for choices in a multiple choice situation, that's what I would be looking for. So hopefully that made sense. I'm sorry I stumbled and stammered and whatnot on this very first one down here somewhere, but yeah. But that's what it amounts to. Negative times negative is positive. I times I is I squared. I squared is negative 1 by definition. Okay. Hopefully that made sense.